This is lesson 48 in Algebra 2, and the name of this section is Radical Equations. And I don't know how much experience you have dealing with radicals, let alone them being in the equation form, but we're going to get started with how to solve for x or whatever variable we have when those variables, the x's or y's or whatever, are under a radical sign. Now, a couple things that we need to look at. Let's say that we have x squared equals 4. Now, if I'm looking for what number can I put in here for x that when I square it I get 4, I have two options. I've got a 2 that's squared that gives me 4, and I have negative 2 that when I square it I get 4. Negative times a negative is a positive 4. Positive times a positive is a positive 4. So those two answers both work. Now let's look at something else. Let's say that x equals 2. And what would happen if I squared this and squared this? I would get x squared equals 4. Alright, so if I squared both sides, I get x squared equals 4. Now let's look at what happens, if I found out what x is. X is, again, plus or minus 2. When I went back, I got an answer for x as being a plus 2 and a minus 2. Well, that's not what I started with. I started with a plus 2. So sometimes when you solve radicals, you're going to get two answers, and when you plug it back into the original, you'll find out that one of those answers doesn't work. And we'll get into that a little bit more. What I just did might seem a little confusing, so we'll do some examples here in a minute. So let's look at an example here, example 48.1. We have x minus 4, and we're going to put that in a radical sign. And then we're going to say minus 2 equals 6. So what we're trying to do here is we're trying to find out what x is. And there are certain procedures in order to find out what x is. For one thing, when we do regular algebra, you have to do what's called isolating the variable, getting the letter, or in this case the x, all by itself on one side of the equal sign. Well, we've got this minus 4, we've got this minus 2, and then we've got this thing here that we can't just make go away. So what we do is we get rid of everything on the left side of the equal sign except the radical, and this is called isolating the radical. So we're going to get rid of that, we'll move it over to the other side, and that equals 8. So once we are at in that place, this here is our next step, isolating the radical, getting the radical on one side of the equal sign all by itself. Then what we do is we're trying to get rid of this radical right here. Well, the only way you can get rid of a radical is if you put it in parentheses and square it, which means you have to do that to the other side of the equation as well. When you square a square root, everything except what's under the square root goes away. The square goes away and the radical sign goes away. And we're left with x minus 4 equals 64. So notice, radical sign went away, makes our life so much easier. Now we just add 4 to both sides, and x equals 68. So when we take that 68 and put it back here in the original equation, we have 68 minus 4 is 64. The square root of 64 is 8. 8 minus 2 is 6. And that works. And that's a good thing. But we always have to plug the answer back in to make sure it works, because it doesn't always work. In fact, let's do this next problem because it doesn't work. So we've got x plus 4, and we're going to put that in our radical sign, and we're going to add 2 and say that equals negative 7. Okay, so let's get rid of the 2. So we will put it over on the other side, and we get negative 9. So negative 7 minus 2 is negative 9. Now we're going to square both sides. and then we're going to subtract 4. Okay, and we get an x value. Yay, we got an answer. Okay, now we have to plug it into the original. So let's do that. 77 plus 4 plus 2 equals negative 7. Square root of 81 plus 2. Whoops, where did I get? That's not a 9, that's a 7. Okay, plus 2 equals negative 7. Alright, let's move all this up a little bit. Square root of 81 is 9. 9 plus 2 is negative 7. 11 is equal to negative 7. That is not a true statement. So therefore, our answer for our x that we got up here, 77, does not work. So there's no answer to this problem. So even though we got x equals 77, when we plugged it in, it doesn't work because of the square root sign. That is what is called, this is a free word for you because we won't go over this for a while. It's called an extraneous root. It means that it works in the equation, but when you plug it in, it doesn't work. So even though it makes the problem come out with the right answer, it doesn't work in real life. Okay, so anyway, you don't have to remember that word extraneous root right now. We'll use it later. Alright, so let's look at example 3. We have x minus 3 under a radical sign. Minus 3 equals 5. Again, we isolate the radical. Take the square root, or we square both sides. We add 3 to both sides. And we get 67. Okay? So now when we plug the 67 back in here, we realize that yes, it does work. It is the right answer, and life is good. Okay, let's look at example 48.4. We have x squared plus 2x plus 13, all under the square root sign, minus 3 equals x. Okay, so let's isolate our radical. Remember, that was the first thing we do. So we add 3 over here. Okay. Then we square both sides. Radical sign comes off. Right hand side we use the our FOIL method. Okay. We move everything around. Notice we have an x squared and an x squared here, the exact same thing, so we can make them go away because they cancel each other out. And we start moving things around so that we get same thing. Let's subtract 2x here, get rid of that one, subtract 9 here, subtract 9 here. So 13 minus 9 is 4, and 6x minus 2x is 4x. Divide by 4, divide by 4, x equals 1 for an answer. And if you plug this back in here, you get 1 plus 2 is 3, plus 13 is 16. Square root of 16 is 4, and 4 minus the 3 that we had here is 1, and that equals the 1 that was on the right hand side. Right here it was just a 1 originally, so that works. And that's it for lesson 49. Not going to go over any of the problem set because A, B, and C are just like what I just did. 6, 7, and 8 are also just like what I just did. So you should be fine with lesson 48.